Today, we're diving into one of the most critical components inside your engine, the valves. At first glance, they might look like simple pieces of metal, but in reality, every single part of a valve is carefully engineered with purpose and precision. Their job is to make sure your engine breathes properly, seals tightly, and delivers the performance it was designed for. Let's break down the terminology of engine valves so you'll know exactly what each section does. First, let's start with the valve head. The head is the flat, round portion of the valve that actually seals against the cylinder head when closed. On the head, you'll notice the valve face. This is the angled surface around the edge of the head. The face makes contact with the valve seat, which is a precisely machined surface inside the cylinder head. Together, the face and seat form a gas-tight seal. This seal is critical because if combustion gases were allowed to leak past, the engine would lose compression and efficiency. Now, the taper angle of the valve face is not the same in every engine. Commonly, it's either 30 degrees or 45 degrees. A 30-degree angle gives a wider opening for airflow, which can improve breathing at lower lifts. On the other hand, a 45-degree angle provides a stronger, more durable seal and better heat transfer from the valve to the seat. Engineers choose the angle depending on whether they want maximum airflow or maximum durability. Next, let's look at the margin. The margin is the thin section between the top of the valve head and the beginning of the valve face. At first glance, it might look unimportant, but the margin plays a huge role in both strength and heat management. A thicker margin means the valve can withstand higher combustion temperatures and resists burning at the edges. But if the margin becomes too thin, either through poor design or after repeated grinding during valve reconditioning, the valve weakens and becomes prone to cracking or warping. Extending from the head is the valve stem, the long, narrow shaft that moves up and down as the valve opens and closes. The stem's job is to keep the valve perfectly aligned as it travels. It also acts as the link between the valve head and the rest of the valve train. Since the stem is constantly in motion, precision is key. The surface must be perfectly smooth to reduce friction and wear. Even small scratches or pitting can lead to oil leakage, valve sticking, or premature failure. At the very top of the valve stem, we find the valve tip. This is the small, hardened surface that comes into direct contact with a rocker arm, cam follower, or tappet, depending on the engine design. Because it's constantly being struck or pressed during operation, the tip must be extremely durable. Some valves even use additional hard-facing or special alloys to prevent wear at this critical contact point. If the tip wears down, it can change valve clearance, affect timing, and ultimately lead to valve train noise or failure. Just below the tip is the keeper groove, a small machine slot where the valve keepers, also called collets or locks, fit in. These keepers lock the valve spring retainer in place, holding the spring under tension. It's a simple but ingenious design because the tapered shape of the retainer and keepers means that the harder the spring pushes, the tighter the keepers grip the stem. Without this system, the spring would fly off the valve during engine operation. So there you have it, a closer look at the key parts of an engine valve and why each one matters. From the head and face to the stem, tip, and keepers, every detail is designed with precision to survive the extreme heat, pressure, and motion inside your engine. Next time you hear your engine running smoothly, remember, those valves are opening and closing thousands of times per minute, keeping everything in perfect balance. Thanks for watching. If you found this breakdown helpful, don't forget to hit the like button and subscribe for more deep dives into engine technology.